Hi, in this video, we'd like to walk through performing an ontologically group differential analysis combination from scratch. So we're on the ontologically group differential analysis tab, and what you can see that you start with are boxes over here with options and boxes over here with options, and then one of three different options over here. Starting with the boxes on the left, we see that we can choose any species or any group of species that is relevant to the species that we have in this database. So we can choose individuals using both their scientific and common name, such as apple, or we can choose groups of species, such as mammals, or even a particular type of node, all species. In this case, we're interested in performing our classic fruit comparison. So we will start with the species, all species, and we will, for the organ, select the fruit. You'll notice that there are multiple entries of the fruit. This relates to the idea that in the mesh hierarchy, the entity fruit has different, it belongs in multiple places according to multiple interpretations. E.g., it can be a food, it can be something that's studied. There are different ways that you can consider the entity fruit. So we'll compare all species of fruit against, in this case, the apple. And now I'll just point out that when you make these entries in one of these groups, you'll notice that the others are actually subsetted. So now we recognize that for the apple, we only have certain types of organs, and we subset the organs in accordance with the species and diseases that we chose. We can now think about if we want to use the known compounds, the compound classes, or the unknowns. The classes are good if you have a more simple query and want to try to aggregate according to, for example, all short chain lipids or something of that nature. We'll stick with the compounds that are known. There are about 700 compounds that are known. There are about 16,000 unknowns. So this is going to be, a little bit faster than using the unknowns. So we'll go ahead and determine the valid triplets in this comparison. And we'll see that in this case, we're comparing, so on the left-hand side of our differential analysis, many different types of things. You'll see that fruits means nuts, fruits means seeds, fruits means the label fruit, et cetera, from all of these different species, coffee, oranges, things like that. And then all the way at the end, we have the right-hand side of our query, our apple fruit. So we're comparing about 26 different types of fruit to one triplet, our apple fruit without disease. We have a estimation of the duration of this query, which is about 25 seconds. And it's also important to remember that when we have multiple types of organs, such as, fruit versus nuts, there may be different extraction methods. That isn't as critical here, but it might be very important, for example, when you're comparing, plasma to liver or something of that nature. So we'll go ahead and perform the differential analysis and give it a few seconds to calculate. And we see primarily the result of this is our volcano plot, where things on the left-hand side are increased in species that are not the apple, and things on the right-hand side are compounds that are increased in the apple. So, for example, our tagatose, a fructose, et cetera. Corresponding to this, we have our data table, where we note that we can use filters if we desire. For example, we can say that we're only interested in fold changes that are less than 2, in which case we filter down this data table, and correspondingly also filter down our summary statistics tables. We can get rid of that if we want. And so we, with our original full data set, can return to our summary statistics to get an idea of what's going on here. We see that there are a number of insignificant compounds, noting the log axes in both of these cases, the log 10 compound count and the log 10 compound count. And we also can notice the the general regions that we chop the volcano plot into. Finally, it's worth mentioning that we can use by default the box select to select compounds, but we can also change to the lasso select if we want to have a distinct region that we want to explore. And we see that when we do that, we're going to update our summary statistics and histograms accordingly. Finally, we see that we can download the data table if we desire. Thank you.